it's always nice to see everyone do this problem correctly. Now, one question came up as I was going around the room. Can you combine the two volumes as one conversion factor? One group said it made sense to them to put the milliliters of sodium hydroxide over the milliliters of HCl as one factor, and that works just fine. On the boards, you'll see that groups did it the way I showed the first time. So we can start anywhere, and if you started with what you wanted, which I had demonstrated, you have 1 mole of HCl per 1 mole of sodium hydroxide. Then we change the moles of sodium hydroxide into liters. Then we look at that ratio from the milliliters to how many milliliters of sodium hydroxide I had to cancel. And it doesn't matter what order you do this in. So in this case, I had started with what I was given, changed my milliliters of HCl into liters so I could keep that, and then I had to deal with the milliliters of sodium hydroxide, so I canceled with the molarity, then I canceled with the mole-to-mole ratio, and you get moles of HCl per liter, 0.116. It doesn't matter where you start, and as wonderful as that is, it becomes that frustrating for students that want to say to me, just show me how to do this. Show me one way that I can memorize and be done with it. And I can't. There isn't one way that works all the time. You have to look at the information you're given and think through your path. So that becomes really frustrating as a learner, that you actually have to learn how to look at the information and think through instead of just memorizing something that always works, because we have such different opportunities with different sorts of problems. Now, as we progress, we want to get fancier and fancier as we're going along. So the next problem is going to combine molarity as a conversion factor for one of the items of interest and molar mass as a conversion factor for the other item of interest. So these get a little more elegant problems, and you have to really think about where am I going and what do I need to get there. So let's look at this one. What is the concentration of the HCl solution? So I want my answer in moles of HCl per liter of HCl. If I have 0.263 grams of sodium carbonate neutralized by 28.35 milliliters of HCl solution. Well, anytime we see grams, it's a clue to us to go look up the molar mass. So 105.988 grams of sodium carbonate per mole. Anytime you see grams, just go do this. And then it'll earn you half a point on the test if you don't know what to do after that. At least you calculated the molar mass. And we know that we have 28.35 milliliters of HCl. And if I look at my equation, it's not balanced, so I'll do that now. Looking at this, it takes 2 HCl's. We get 2 sodium chlorides, and everything else is a 1. So now we can look at this and say, what is the mole-to-mole ratio for sodium carbonate to HCl? Well, I have 1 mole of sodium carbonate for 2 moles of HCl. So I've balanced the equation, I wrote down all my conversion factors, and now I have to calculate. And you think, where do I go from here? Where do I start? You can start anywhere. So as a group, where do you prefer to start? With what you want. I'm hearing one voice, what you want. I think it helps. So I want my answer in moles of HCl per liter of HCl. So let's start with something that will help me. And let's just start with moles of HCl on top. So I have 2 moles of HCl uses 1 mole of sodium carbonate. I want to keep that moles of HCl. This is the unit I want to end up with on top, and I'll deal with the liters later. So now, how do I get rid of my moles of sodium carbonate? Well, I use my molar mass. 1 mole of sodium carbonate has a mass of 105.988 grams of sodium carbonate. Now I have grams of sodium carbonate and I need to get rid of that. So I'll use this 0.263 grams of sodium carbonate. And one group said, well, we like to think of them going together. So if you wanted to put this milliliters on the bottom here, you can. This many grams of sodium carbonate reacted with 28.35 mils of HCl. So now I've canceled my grams and I have milliliters on the bottom and I want liters on the bottom. So 1,000 milliliters is 1 liter. Now, if you didn't put this on the bottom here, you could have stuck it over here on the bottom. And you would just put it in there because you want it on the bottom. So now my milliliters cancel, and I get 0.175 molar HCl. So I really find it useful to start with what you want when you're wanting to end up with a 2-part unit. That way you don't end up upside down. Okay, do you have any questions? Yes. Yes, in this case, I mean, you could change molarity into percent, but why would you want to do that? We haven't done any other concentration unit yet except molar. So for this chapter, for this class, if it says concentration, we're talking about molar concentration.